2.4 is all about the structure of metals and alloys. So remember that the valence electrons in metals are delocalized, meaning that they freely float between the atom's nucleus. Sometimes this is referred to as the sea of electrons, where this concept leads to all of the properties of metals. They're ductile, they can stretch into wires, they're malleable, you can hammer them into different shapes, they can be shaped in different ways, and so this free floating of electrons between each of the nuclei involved allows for these properties to happen. So in this picture, the red plus are the ions, fixed position, so it's the nucleus of the metal ion, and then all of the electrons are just freely moving around wherever they want to go. So they're freely being shared, but it's not like a covalent bond because it's all the same type of atom. Because of the nature of the structure and bonding of metals, other elements can be introduced in a metallic crystal, relatively easy to produce alloys. So remember that alloys is a substance that contains a mixture of elements and has metallic properties. Usually at least one part of an alloy is a metal to help with those metallic properties. Two important ones that you need to know are substitutional alloys and interstitial alloys. So a substitutional alloy is where you have a host metal where some of its atoms are replaced by atoms of similar size that are also metal. So the first example I have for substitutional is brass. Brass is made out of copper and zinc. Copper is the host metal, and zinc is very similar in size to copper. They are right next to each other on the periodic table, so there's only a difference of one proton and electron there. And so they mix together well to make brass. We use a lot of brass in our world. An interstitial alloy is formed when some of the interstices, I hope I said that right, which are the holes in between the metal structure, are occupied by smaller atoms. So a great example of this is steel. Most steel contains some kind of carbon. So the carbon ions the carbon atoms, are a lot smaller than the iron atoms. So wherever there's the empty space, the holes, that's where the carbon can fill in for an interstitial alloy. On the AP exam, you might have questions, or even on your quiz or on your test, you might have questions where you might have to pick the best one or explain why is this way based on these two alloys. So that's a nice short 2.4.